Hi, my name is Anish Sankaratri, and this is my project 1.1.6 compound machine for STEM Principles of Engineering for Mr. Bennett's class at Walton High School. So, the goal of this project is to create a compound machine with 4 distinct simple machines to lift an object with a mass of 1 kilogram above 30 centimeters off the ground. So, my machine has 4 distinct simple machines, which is a wheel and axle, sprocket and chain system, gear train, and a pulley. So let me explain them in further detail. So our wheel and axle here is our input, our user input force. The user inputs their force by turning the wheel. So since the force is being applied to the wheel, our IMA calculations would be 4 divided by the axle's diameter, which is 0.125, therefore making our IMA 32. Our wheel and axle system shares an axle with this chain and sprocket system. The chain and sprocket system's gear ratio is dependent on the diameter of the gears in the chain and sprocket system. So, we have this gear with a diameter of 3 inches and this gear with a diameter of 2 inches. So, our chain and sprocket system's gear ratio is 1.5. Our chain and sprocket system's driven gear is attached to our gear train's driver gear. Our gear train has a consistent of 3 gears, 1 60-tooth gear, 1 36-tooth gear, and 1 84-tooth gear. Since gear ratio is calculated as driven over driver, it is 84 over 60, making our RMA 1.4. Then we come to our other wheel and axle system, which in this one, the force is being applied on the axle. So, therefore, switching our fraction of 1/8 divided by 4, therefore making this system's IMA 0.03125. Our wheel and axle system pulls on our pulley, which pulls on the string to lift up the weight. So as you can see here, we start off with a object with 1 kilogram mass or 2.2 pounds weight, and we start at 0 inches. Then our goal is to get above 12 inches or 30 centimeters, and my goal is between 18 and 24 inches. The total IMA of this system is 2.1, and the user inputs around 564 grams. So our AMA would be 1000 divided by 564, which is 1.773. So our efficiency is 1.773 divided by 2.1, or 84%. So this machine is 84% efficient with friction. So let me show you how all 4 machines work in conjunction as one compound machine to lift up our weight. So as you can see, as I turn, the wheel here is turning our chain and sprocket system, and that is turning our gear train, that is turning our wheel and axle, and that is turning our pulley. And as you can see, our pulley is pulling the weight up to our desired goal. And yeah, there we go, we met our goal. So, some problems and issues I faced while building was that when the pulley was pulling up the weight, if the weight was too heavy, these support bars would start to bend this way. To avoid that issue, I built these support rails that are directly connected to the base, therefore making sure that if it came down, it would be counteracted with these support rails, therefore keeping it straight. Same thing here. If the user put in too much force, or if the machine is collapsing inward, these rails would stop it. All in all, this was a fun experience to build, and thank you for watching.